All right, hello everyone, this is Miss Piekarski. I'm doing this video for those of my students who were absent on Wednesday, April 29th. I have a couple students that have asked me to post this recording, and if there's anything that we did in class today that you didn't understand, this will help you. It'll help you by going over this again. Okay, so a couple things that we did today. Number one was practice graphing the parametric functions for our conic shapes. So these two would be ellipses, and you can graph them by hand just by finding the center point. So for 5, your center of the ellipsis is going to be at 4 and -3. And then the horizontal radius would be 8, and then the vertical radius would be 5. And then this one over here, you can do the same thing. The center of your ellipsis would be at 4 and 0. Because you're not adding or subtracting any numbers here, then the center would be at 4 and 0, and the radius would be 8 here. The horizontal radius is 8, and the vertical radius is 5. Okay, so let me just show you what these two graphs would look like. Let me see. I need to click on that. There we go. All right. Order. So if you do it by hand, you just first find the center point. So this one was at 4 and 0 and 2, 3, 4. So like right here, and then you count 5 up, 5 down, and then 8 over and 8 over this way. And then just draw your circle, your ellipsis as neatly as possible. I'm not going to be super picky on it. And then this one, your center was at +4 and then -3, so approximately right there. And then you did 8 over this way, 8 over this way, and then 5 up and 5 down. Okay. If you have to plug this into the calculator, or if you want to plug it into the calculator to find your graph, you first want to click on the mode button in the old calculators, and then go make sure it's in degree mode and make sure it's in parametric mode, and then you're going to want to change the window. So you push the window button, and you'll find that most of the time when we're graphing conic functions, your t-values are going to be from 0 to 360 and then a step of 5. And most of the time, your x minimum and x max will be like this, and your y minimum and y max will be like this. Okay, so you might want to maybe jot those down in the notes somewhere in your notes so you can remember it. I had my students graph these in the calculators. Remember, with the old calculators, most of you don't have the secant button. If you don't have the secant button in the calculator, you can just take this function here and do 2 divided by cosine t in the calculator. Over here where you have the secant, it would be 5. You can, let me see, this equation would be the same as doing 5 plus, and then do 4, and then divided by cosine t here. Okay. These will be hyperbolas, and most of my students are like, well, how do I do a hyperbole? Okay, or hyperbola by hand. Okay. So you should be able to do these by hand or in the calculators. I need you to know how to do it both ways. So the first thing is find your h and k. That's telling you where your center is. So in this case, for number 24, your center is at 5, 1, 2, 3, 4, 5, and then down 2. So the center of your hyperbola is right there. And because secant is paired up with the x formula, my hyperbola is going to open left and right instead of up and down. Now for number 20, your hyperbola is going to open up and down because the secant is paired up with the y formula. Okay, just depends on which formula has secant in it. All right, so now I'm opening side to side for number 24. I want you guys to do 21 and all the other problems on where you're graphing your hyperbolas. All the other problems in the worksheet you should do on your own. So back to number 24, we'll do this together. Okay, so we're opening side to side, and the horizontal radius is 4. So I'm going to go 1, 2, 3, 4, and I know that my vertex is going to be right there. Okay, and then I go this way 4, 1, 2, 3, 4, and I find this vertex is over here. And then I need to know basically how wide it's going to be. And so the corner of my box, remember your boxes, will fit like this. The reason why I know that is because the box is going to be, it's going to line up where the vertices touch, and then my my vertical diameter is 2 here and here. So I know that, let me change it to red. I know that my asymptote is going to go from this corner, point there, and then this way. And then this asymptote is going to go like this. Man, it's really hard to do this with my finger. Okay, so that tells me this red line is my asymptote. So that tells me that my hyperbola is going to fall like this. So it's going to be kind of like that. And guys, I know this is a rough estimate on what the hyperbola looks like, but we get the basic idea, right? And this would keep on going. All right, so if you had to graph this by hand, this is basically what it would look like. You wouldn't see these dotted lines, you wouldn't see this center point, and you won't see the red lines where the asymptotes are, okay? All right. So now write parametric equations for each of the following ellipses. In class, I only did problem number 11 with the students because it's pretty easy. Okay, first of all, your center point here is going to tell you what numbers you're adding or subtracting to your trig function. So because you have a 5 here, you're going to add a 5 to your cosine function. And we know it's cosine because cosine is always paired up with your x value, and sine is going to be paired up with your y value. So I have cosine here and sine here. The 5 comes from here. Well, if you add 0, that's going to be for the y. You would do plus 0. Well, you don't have to hit plus 0. It's stupid. You know, it doesn't change the value. So we're not even going to write that down. But now we need to figure out what the radii are. So your horizontal radius, you're starting from the center and you're going 2 units to the right and to the left. So your horizontal radius is going to be 2. And then your your vertical radius is from here to here, so 7 units. So we're going to multiply by 7 there. Okay. I want you guys to do problems 10 and 12. You should be able to do those on your own pretty easily. Remember, your cosine is paired up with x, and sine is paired up with y. And then you'll have to figure out what to do with the center of the circle and the radius, okay? You should be able to do those just fine on your own. All right, so back to the notes. This is a page in your notes. Hopefully you remember how in the parametric unit, how we eliminated our t value and we got just a regular equation. Okay, so well, we're going to do that basic same kind of thing, except we're going to get rid of cosine and sine and t all at the same time. To do that, we're going to use our Pythagorean identity, cosine squared theta plus sine squared theta equals 1. Okay, hopefully you remember that from last semester. It's one of our trig identities. It's a pretty awesome one. I will caution you when you're looking in your notes, make sure you are looking at the notes that have, oops, that's not what I wanted to do. That's what I wanted to do. Okay, sorry. Make sure you're looking at the page that has this information right at the top. If there's anything else about secant and tangent, you're on the wrong page. So don't copy this information down on the wrong page, okay? All right, so moving on. Let's make sure you're in the correct page. Let me move that there. All right, so basically what we're going to do, we want to solve for cosine t and we want to solve for sine t. We want to get those all by themselves. And so we're going to get rid of the 3 and get rid of the 6, get rid of the 1 and get rid of the 4 that's over on the right side. We want all of those to be on the left side. Okay? And then to do that, let me move this up so we can see it better. To do that, we subtract 3 from both sides, divide by 6, add 1 to both sides, divide by 4, and this is what we get here. Well, now we're going to take these formulas, this and this, and substitute it in for the cosine and sine in your Pythagorean identity. Okay, so we're just taking x minus 3 divided by 6, we're plugging it in for cosine, and y plus 1 divided by 4 gets replaces the sine t. Okay, and then we get this. And then you always want to, if you have a fraction, you always want to go ahead and separate the numerator and denominator by just squaring the denominator, okay? So here, notice your numerator stays the same, just x minus 3 squared, but then the 6 here becomes 36, and the 4 here becomes 16, okay? So 6 squared is 36, and 4 squared is 16. Now, I will caution you, some of my students are doing this. They're going to they square the diameter, and then they draw their parentheses like this again. I don't know why, because when they do that, they're saying that, okay, now you need to square these again. You don't square them. So twice. Once you've squared the diameters, leave them out of the parentheses, okay? All right, so let's look at problems 13 and 15 that are in your notes, and then you can work on problems 14 and 16 on the worksheet. Okay, so if you were going to solve for cosine t, you would subtract by 7 and divide by 4. So your equation would be x minus 7 divided by 4. And then for sine, you would subtract by 5, divide by 2. So you would have y minus 5 divided by 2. Okay, next step, you want to plug both of these equations in for your sine and cosine, okay, in the Pythagorean identity. Okay, then let's separate the numerator and denominator by squaring our denominators, and your final answer is this here. Okay, same thing for 15. Solve for cosine, solve for sine. Pretty easy. You get x plus 1 divided by 6 and y minus 3 divided by 1. The reason why I'm showing you this is, yes, I know that most of the time when you're dividing by 1, you don't have to actually put divided by 1 there. We already know. But because of what we're going to be doing later on in this unit, I want you to go ahead and leave the divided by 1 there. It will help you tremendously to visually see the dividing by 1. All right. So next step, plug it into the Pythagorean identity. Then next step, you square the denominators, and then you just have the numerator in parentheses, okay? Should be simple. Go ahead and try problems 14 and 16 on your own. You should be fairly easy to do. All right, so now 17 and 18, you want to do everything that we just did, but backwards. Okay, so we're going to, you have the rectangular form of your you have the rectangular form of your ellipse, and you want to create the parametric form, okay? First things first, what do you know? Let me do that. What do you know about your parametric functions? Cosine always cosine always pairs up with your x, okay? So the first part of your equation, just get that cosine in there. And then sine is always going to be paired up with your y value, okay? Now, remember how we squared some number to get 49, and we squared some number to get 20. So the opposite of that would be square rooting it. Well, the square root of 49 is 7. And then we have a minus 11 here. To the opposite of minus 11 would be plus 11. Okay? You're not adding or subtracting anything to your y values, or the y, so you're not going to worry about that. But then the square root of 20 is a like 4 point something. I don't want you to give me a rounded answer. So most of you will probably just put the square root of 20. But don't forget, you can reduce that, and 20 reduces, the square root of 20 reduces to 2 times the square root of 5. I do want you to go ahead and reduce those because I know you know how to do it. So do not write this. I want this as your answer, okay? Go ahead and try the same process for number 17. Just work your way backwards. You're square rooting these numbers, and then if it's a minus here, it'll be a plus. If it's a plus here, it'll be a minus, okay? All right. Now let's look back at your notes. This is another Pythagorean identity. So we know sine squared plus cosine squared equals 1. And if you recall from your trig identities unit last semester, we also had a slight variation with 1 plus tangent squared equals secant squared. And then if I want tangent and secant on the same side of the equation, then I would get this formula. And please go ahead and draw a rectangle. We're going to pretend that's a very nice, even, smooth rectangle. Doesn't look very smooth, but that's okay. We can pretend. Anyway, go ahead and draw a rectangle around this equation. Let me see if I can get it to work. There we go. Now it's all nice and pretty. Draw a rectangle around that equation, because when the instructions tell you to write a rectangular equation, you're going for the hyperbolas. This is the formula that you want to use, okay? So rectangular equation. All right, so now the process that we used for the ellipse and sine and cosine is the same process for tangent and secant. You're just solving for tangent t and solving for secant t. Okay, so you're going to subtract by 3, divide by 6, and this becomes let's see. So then tangent t becomes x minus 3 divided by 6, and then secant will become, let's see, add 1, divide by 4, so y plus 1 divided by 4. Okay, then you're just plugging it into your Pythagorean identity, but this time it's the secant squared x minus tangent squared x. Okay, so we're plugging these equations in for tangent and secant. And yes, I know that this is a t and this is an x. It's okay, it's the same thing. Okay, so plug those in and you get this equation here. Okay, so basically all we did is we eliminated our secant and our tangent and our t value. All right. Let's see, was there, oh, don't forget, it does not matter where your secant equation is. If secant is paired up with the y's, then this is what is going to go up front, okay? And then if secant is paired up with x, then your x formula will be up front, okay? So it just secant minus your tangent, okay? Keep that in mind, memorize it. All right. On your worksheet from class today, I can't remember what it was called. Parametric conics, I think is what it's called. I don't know. I think so. Anyway, so from this worksheet, excuse me, you were supposed to have 4 problems on the very back, and they were not on there. So 2 of them, 30 and 32 are 2 of them. The other ones are 31 and 33. You can pause this and write these 4 problems down on the back of your worksheet really quickly. And I'm going to do problem 30 with you guys. So you have tangent and secant. You're solving for secant and tangent and getting everything else on the other side. So you're going to, with the x, you're going to subtract by 7, so you have x minus 7 in the numerator, and then divide by 4 in the denominator. And then for tangent, you subtract by 5 and then divide by 2, so it's y minus 5, and then divided by 2. Okay, and because my x formula was paired up with tangent, then x is going to be out front, or sorry, the x formula is paired up with secant, so this part is going up front, and then minus the y formula. Okay, all right, so that's the end of the videos. You've got problems 30, 32, 31, and 30. Those 4 problems should be on the back of your worksheet. Go ahead and write them down, answer them, and then turn them in the next time you're in class. All right. Hopefully this video was helpful. If you are having problems or struggling, email me. I might be able to help you. All right. Bye.